In last lecture, we discussed about some properties of multivariate or some results of a matrix algebra. Okay, and last we have also seen the moment generating function for a vector x. If x is a random variable, okay, which is a vector having a p elements, then what is the moment generating function of that? That we obtained. Now we will talk about the conditional distribution, expectation, and corresponding moment. Now suppose if x is a vector having a p element, so it is a vector of p element. So let us say x is a vector of p element, and if we partition this vector into the two parts, one part having a q element and second part is a p minus q element. That means in the first part we can have the variable x1, x2, xq, and in the second part we have a xq plus 1 to xp. Then the conditional distribution of x1, x2, xq given xq plus 1 up to xp is, so we can denote it as a f of x1, x2, xq given xq plus 1 up to xp, in bracket x1, x2, xq given xq plus 1 up to xp is equal to. So how to obtain the conditional distribution? So we know that conditional distribution is nothing but if f of x given y, it is nothing but f of xy divided by f of y. So you have to write the joint density of x and y, and you have to divide this joint density by the marginal of y. Then you can get the conditional density of x given y. So similarly here we wish to find out the conditional distribution of x1, x2, xq given xq plus 1 to xp. So how to obtain this? It is nothing but the first you have to find out the joint density. So joint density is nothing but f of x1, x2 up to xp divide by. So how will you get this marginal density, or it is a density of q1 plus q2 up to p? So just you have to integrate over the joint density with respect to x1, x2, xq, because I am interested to find out this is the q. Okay, so if you integrate the joint density with respect to x1, x2, xq, you will get the density of a x1, x2, xq plus 1 up to xp. So it is nothing but the joint divided by the corresponding density of xq plus 1 to xp. And if you are interested to find out the conditional mean, so how will you find out the conditional mean? Let us say if I am taking q equal to 1, that is the conditional mean of x1. When I am taking q equal to 1, what happen in this setup? Q equal to 1, so in the first part it is x1 and the rest of the part it is a x2 up to xp. So I am interested to find out the conditional mean of x1 given x2 up to xp is defined as expectation of x1 given x2 up to xp is nothing but integration of x1 f of x1 x2 xp dx1 divided by, because here how many you can have only joint density. So actually you can write in this way. I think x1, this is x1 x2 xp, okay, dx1 and divide by the whole. So it is nothing but integration of x1, and this is the conditional density of x1 x2 x1 given x2 xp and this. So it is known as denoted as a m of x1 given x2 up to xp. In short, whenever you wish to find out the conditional distribution of x, sorry, whenever you wish to find out the distribution of x or the expectation of x, what is the formula? X fx dx. But if here, if you wish to find out the conditional expectation of x given y, so for that you require to, it is a x and f of x given y and then dx. So here, similar way, you can see that it is a, because I am interested to find out the conditional expectation of x1 given x2 xp, so I have written the density as a conditional f of x1 given x2 up to xp, and you have integrate over the dx1, which is giving the conditional expectation of x1 given x2 xp, and we denote it by m. Is that clear up to here?
Yes, sir.
Okay, it's very simple things. Now we will use that concept. Our basic idea is that we wish to talk about the regression. So you all have studied the concept of regression at your BSc level. It is something like that you may have studied y equal to beta 0 plus beta 1 x plus epsilon, where beta 0 and beta 1 are the parameters of the regression models. Y is a dependent variable, x is independent variable, and this epsilon is the errors, and it has the normal with mean 0 and variance sigma epsilon square. So beta 0 is known as the intercept parameters, okay, and beta 1 is said to be a slope parameters. So for a given a value of x, what is the expected value of y? The expected value of y is nothing but beta 0 plus beta 1 x. Okay, so that we know. And why it is known? Because expectation of epsilon is 0. And that is how, if you find out expectation of y, it is nothing but beta 0 plus beta 1 x. Expectation of epsilon is 0, so expectation of y is beta 0 plus beta 1 x. Now we have given the vector of p component. So this p component is given, and what is my objective? The problem of regression is to predict about the dependent variable on the basis of independent variables. So here you can say that y is a dependent variable, x is independent variable, and our problem is that we wish to know the value of y based on the value of a x. So x is independent. The choice is in your hand. Given a value of x, what should be the value of y that you can obtain, and that concept or that things you can be obtained by using the concept of regression. But here beta 0 and beta 1 are unknown, so therefore you have to estimate the value of the parameters beta 0 and beta 1 such that the given a value of x, you can have the best predicted value of y. So what is the best criteria? So that we will discuss. The problem of regression is to predict about the dependent variable on the basis of independent variables. So let x is equal to x1, x2, xp. If you partition this particular x into the two part, in the first part you can have a x1, and the second part you have a x2, x2 up to xp. So here you have only one element. Here you have a how many? P minus 1 elements. Then the conditional mean of x1 given x2, xp is called the regression of x1 on x2, x2, xp. So whenever you are trying to find out the conditional mean of x1 given x2, x3, xp, it is nothing but it is indicating the regression of x1 on x2, x3, xp. Okay? So in general, suppose we say that here you can see that what is the relation between y and x? Here what is the relation between y and x? It is a linear in parameters, because what is the power of beta 0? It is 1. Power of beta 1 is 1. So we can say the relation between y and x is linear in parameters. So x to xp is nothing but when you establish the relation between x1 and x2 xp, so this has this certain function, and this function we call them as a g. So in general, the effect of independent variables x2 up to xp is a function of x2 x3 xp, and which is denoted by the g of x2 x3 up to xp. Okay, so in short, the relation is something like that. You have this x1 is some function I call it is a g, it is a x2 xp. Now what is this function I am interested to find out? So actually this is the kind of relation you have. If you write, it is a g of x2 x3 xp plus epsilon. So our aim is in the regression is that we wish to find out the value of the g. That means what is the functional relation between x1, x2, xp, and we wish to find out the how we obtain this. We obtain by minimizing the epsilon. So it is some functional relationship. The choice of x g of x2 xp is done by how will you find out the suitable choice of g? So by just minimizing this quantity. Now if you write this, what will you get? X1 minus g of x2 up to xp is equal to epsilon. So epsilon is a error term. It is nothing but x1 minus this is the g x2 xp. It is a some true value. So the observed value minus true value, we call them as a error. Okay. So this is epsilon, and ultimately we wish to find out that epsilon should be minimum so that x1 is very close to this function. So we can say that this x2 xp are really good to predict the value of x1. So if we wish to minimize this, so epsilon is a small quantity, so epsilon square is also a small quantity. So we wish to minimize the square of this. Okay. So this is what it is saying, that the choice of gx to xp is done by minimizing the expected value of x1 minus g of x2 xp of xp whole square. So how to minimize this? So now what we do, I know that what is the mean of x1. The mean of x1 I have denoted as a m of x1 given x2 xp. So what I do, I will just subtract and then I will add this quantity in this quantity. So I can get this x1. I have subtracted this quantity plus added this quantity, and then I am writing this quantity as it is, g of x2 xp. Now if I am this is nothing but this is a one quantity and this is the another quantity. So it is nothing but the something like that. You can have x plus y square. So what is that? It is a x square plus 2xy plus y square. Now what is x? X in our case x1 minus m of x1 given this quantity, and I am saying this is a y, or you can say it is a or b, whatever you say. Now, so this quantity I have written here, expectation of x1 minus m of x1 given x2 xp whole square, and y square. So y is nothing but this. So I have also taken the expectation of the square of this quantity. But what about this product? Anyone? What happened to this product? Where it goes? Any idea? Anyone? Am I audible?
Yes, sir. जीरो होगा शायद सर।
जीरो हो जाएगा। क्यों जीरो हो जाएगा? क्योंकि इट इज ए टू टाइम एक्सपेक्टेशन ऑफ एक्स वाई। ओके, क्योंकि आप एक्सपेक्टेशन इनसाइड ले जाएंगे तो टू, व्हाट इज एक्सपेक्टेशन ऑफ एक्स वाई? एक्स क्या है? दैट इज एक्स वन माइनस एम ऑफ एक्स वन गिवन एक्स टू अप टू एक्स पी इन टू क्या होगा? y क्या है? तो हम जानते हैं कि g इज ऑल्सो फिक्स बिकॉज एक्स टू एक्स पी आपके हाथ में, तो इट इज ऑल्सो फिक्स एंड एक्सपेक्टेड वैल्यू इट इज अ पैरामीटर, तो दैट इज ऑल्सो फिक्स। तो वो क्या हो जाएगा? दिस क्वांटिटी जस्ट आउटसाइड ऑफ एक्सपेक्टेशन, so this is expectation of x1 minus this, but what is the mean of x1? Mean of x1 will be this, so it is nothing but expectation of x1 minus this quantity, and expectation of x1 equal to this, so that means both the quantity are same, then the difference is zero. So zero into anything, it becomes the zero, and that is how this quantity is not in our next term. Is that clear? Am I right? Because
यस
we
सर।
know that expectation of x1 given x2 xp is nothing but m. Okay, so this is we know, so that's why this become the zero. So zero into 2 into this quantity, again it is a zero. So now you can have a these two term. Now suppose this is a some value, this is the mean of x1 given x2 xp, and this is a some function of x2 xp. So this is nothing but it is a some वैल्यू, एंड वैल्यू का स्क्वायर लेंगे तो क्या होगा? नेगेटिव या पॉजिटिव, उसका स्क्वायर क्या होगा? इट बिकम दी पॉजिटिव, and if this is a positive quantity, so you can see that this quantity is a sum of two positive quantity. So if I am just removing this quantity, what happen? This quantity is nothing but the sum of two positive quantity. If I am removing this quantity, then what happens? This quantity is the higher than this, and that is what it is written, that expectation of x1 minus g of x2 xp whole square is greater than of expectation of x1 minus m x1 given x2 xp whole square. So which show that this quantity m of x1 given x2 xp is the proper choice of a g of x1 x2 xp, क्योंकि हमें तो क्या चाहिए? We wish to find out the value of g such that this quantity should be minimum. तो ये क्वांटिटी कहाँ मिनिमम होगी? इफ यू टेक दिस फॉर्म, क्योंकि इससे तो ये क्वांटिटी मिनिमम हो गई ना. So that means the suitable value of the g of x2 xp is nothing but m of x1 given x2 xp. So that is what it is written that. And so that regression line of x1 on x2 is given by x1 equal to m of x1 given x2 up to xp. So we know that expectation of x is equal to this. Okay. And now if we assume that the mean is zero, then what happens? So in short, in the earlier slide, what we have seen, in earlier slide, we have shown that the regression of x1 on x2 xp is nothing but expected value of x1 given x2 xp, provided that x1 x2 xp are jointly distributed, and it is given by m of, that is the conditional mean of x1 given xp, x1 given x2 up to xp. Now if I am partitioning my x into the two part, what is that? X equal to x1, this is x2 xp. So I'm partitioning my x into the two part. This has the one element and this has a p minus 1. And if I'm saying that this is a x1, this is a x2, it is a vector. and this x2 have having how many element? This x2 has this x2 up to xp element. Okay, so what is the mean of x? What is the mean of x? Expectation of x is nothing but expectation of x1 x2. So it is as good as it is expectation of x1 expectation of x2. Okay, whatever mean you have taken, suppose if you have taken the 0, then this become the 0, entire 0. X1 is 0 and this has the also 0. So, and if you wish to find out the variance, what happened to the variance? Variance of x, so it is given here. Variance of x is equal to variance of x1 x2. And how will you find out the variance? So we know that variance of x is nothing but, remember the property, it is a expectation of x minus expectation of x into x minus expectation of x transpose. Okay, so this is, so we have used the same things here. The variance is written as this. Now what is x? X is nothing but x1 x2. Expectation of x is nothing but expectation of x1 x2. Similarly we are writing. Now what we do, we have assumed that this is mean is nothing but 0. You can see the previous slide. What we assume, we have assumed that the mean is 0. So mean is 0, that means this form is reduced to expectation of x1 x2, and this is a transpose, so this column become the row, so it is nothing but x1 x2 transpose. Now what we do, this x1 multiply with x1, what we get? It is a x1 square. Okay, if this x1 multiply x2 transpose, so it is nothing but x1 x2 transpose. Here it is a x2 x1 and here x2 x2 transpose, and expectation is outside, so if we take inside, it is the expectation of x1 square, expectation of x1 x2 transpose, expectation of x2 x1, and expectation of x2 x2 transpose. So what is the order of this matrix? What is the order of this matrix? Anyone?
2 cross 2.
What is? क्या आएगा order? How many elements it has?
4.
यहाँ तो कितनी रो है? ये एक रो है, लेकिन यहाँ पे कॉलम कितनी है? ये एक है, लेकिन इसके अंदर कितने एलिमेंट है?
P minus 2.
माइनस 1. तो इसका ऑर्डर क्या हुआ? दिस इज ए p माइनस 1, दिस इज ए 1. इसका ऑर्डर क्या है? इट इज ए p माइनस 1. तो ये 1 p माइनस 1, तो ऑर्डर क्या हुआ इसका? p क्रॉस p. So this matrix has the order is p cross p. How many elements it has? A p cross p element. So what is the variance of x1? Variance of x1 is nothing but expectation of x1 square minus expectation of x1 होल स्क्वायर. बट हमने कहा है मीन तो क्या है? 0 है, तो ये
0.
क्या हुआ? एक्सपेक्टेशन ऑफ x1 स्क्वायर. इसकी जगह पे क्या लिख सकते हैं? वी कैन राइट वेरिएंस ऑफ x1. दैट इज व्हाट इट इज रिटन एज ए वेरिएंस ऑफ x1. Similarly, if you find out the covariance, how will you find out the covariance? What is the formula of covariance? Covariance of xy is nothing but expectation of xy minus expectation of x, expectation of y. So that is the same thing. Here it is nothing but x is x1 and y is nothing but x2 transpose. So it is a x1 x2 transpose minus expectation of x1 expectation of x2 transpose. लेकिन expectation of x1 क्या है, जीरो है, expectation of x2 transpose क्या है, जीरो है. तो this quantity is vanished. So you can have x is equal to you have a x1 and y is equal to you have a x2 transpose. So that is nothing but the covariance between the x1 and x2 transpose. So that is how it is written here. This. Similarly, here there is a mistake. This should be a transpose. Okay. When it is a transpose, then only then you can have. Okay. So this is nothing but the covariance between the x2 transpose and x1. And here it is a variance of x2. Okay. So what if I am denoting variance of x1 as a sigma 1 1 and covariance between x2 transpose and x1 as a sigma 2 1 and covariance between the x1 x2 transpose as a sigma 1 2 and covariance between the x2 x2 transpose, or you can say that variance of x2 is denoted as sigma 2 2. So I can write it as a sigma 1 1. So it is nothing but variance of x, and I can call it as a sigma. So variance of x is equal to matrix of sigma 1 1, capital sigma 1 2, sigma 2 1, sigma 2 2. Okay. And what is the order of this sigma 2 1? What is the order of sigma 1 2? It is a p cross, sorry, p minus 1. So 1 cross p minus 1. Let me show you. I am adding, let us say, new slide here in between. So when I am saying that, what we written? Okay, sigma is nothing but variance of x, and it is nothing but sigma 1 1, sigma 1 2, sigma 2 1, sigma 2 2. So you can see that it is a partition matrix. इसका ऑर्डर क्या है, ओवरऑल p क्रॉस p है. इसका ऑर्डर क्या होगा, ये एक ही स्केलर है, दिस इज स्केलर, इट इज ए 1 क्रॉस 1, दिस इज ए 1 क्रॉस p minus 1, this is a p minus 1 cross 1, and this is a p minus 1 cross p minus 1. That means sigma 1 2 has the order 1 cross p minus 1. ये आपको याद रखना और समझना भी है. Sigma 2 1 has the order p minus 1 cross 1. So when I am saying that p minus cross 1, it means that how many element it has a? It has a p minus 1 elements in a column. Here it has a how many elements in the row? P minus 1 element in a row. And further, we know that the sigma 1 2 transpose is nothing but sigma 2 1. So these two are the symmetric of sigma 1 2 is a transpose of sigma 2 1. And what is the order of sigma 2 2? Sigma 2 2 is order of sigma 2 2 is p minus 1 cross p minus 1. From where I have written from this. How many rows are there? P minus 1. How many columns are there? P minus 1. So that is how the order is p minus 1 cross p minus 1. And this is sigma 1 2 is nothing but it is a expectation of x1 x2 transpose. तो व्हाट इज द x2 में क्या है, x2 ट्रांसपोज में क्या है, x2 इज ए कॉलम वेक्टर, तो x2 ट्रांसपोज में क्या हुआ, x2 x3 xp, ठीक है। तो ये x1 इसके साथ मल्टीप्लाई होगा तो क्या मिलेगा, एक्सपेक्टेशन ऑफ x1 x2 कॉमा एक्सपेक्टेशन ऑफ x1 x3 कॉमा अप टू एक्सपेक्टेशन ऑफ x1 xp। तो इस हिसाब से रहता है, दिस x1 मल्टीप्लाई x2 फिर कॉमा, तो दिस इज द वन एलिमेंट हुज एक्सपेक्टेड वैल्यू, x1 multiply x3 and then you take expected value, this is the covariance between x1 and x3, and likewise it is a covariance between x1 and xp. Similarly, if you are writing the sigma 2 1, so as I said that it has a p minus 1 element, तो उसका क्या होगा, it is a expectation of x1 x2 expectation of x1 x3 up to expectation of x1 xp, and this is giving the covariance between the x2 transpose and x1, okay. सॉरी, यहाँ पे मेरी मिस्टेक है, ये ट्रांसपोज नहीं आएगा, ये बराबर है, दिस इज करेक्ट, बट व्हेन यू टेक द ट्रांसपोज ऑफ दिस सिग्मा 1 2 ट्रांसपोज इज इक्वल टू एक्सपेक्टेशन ऑफ x1 x2, ये ट्रांसपोज है, उसका आप क्या लेंगे, पूरा का ट्रांसपोज लेंगे, तो हम जानते हैं कि वो क्या होगा, चेंज होगा, एंड दैट इज नथिंग बट एक्सपेक्टेशन ऑफ, जो सेकेंड स्टेप है वो पहले आ जाएगा पॉइंट, तो वो उसका x2 ट्रांसपोज का ट्रांसपोज, इट इज x2 एंड x1 ट्रांसपोज इज ए स्केलर, x1 इज ए स्केलर, तो उसका कोई ट्रांसपोज नहीं होता है, इज दिस, एंड इट इज ए सिग्मा 2 1। तो जो अर्लियर स्लाइड में मैंने लिखा था, इट इज नॉट द ट्रांसपोज, ओके, यहाँ पे समझ रहा है रिटर्न, दिस इज करेक्ट, ये मेरी गलती थी, तो काइंडली करेक्ट दिस। ये वाला जो है, ये वाला ट्रांसपोज नहीं आएगा, इट इज प्योरली x2, ठीक है, बराबर था, ठीक है। Why this is very important, because when we introduce multivariate normal distribution, where we say that x is a p component vector having a multivariate normal distribution which has the certain density and which has the mean mu and variance covariance matrix is sigma, this is nothing but the variance covariance matrix p cross p, and that is nothing but the variance of component vector x or vector x. So what is our aim? As I was talking about, that we wish to find out the regression of x1 on x2. So let us obtain regression of x1 and x2, xp is denoted by x1 on x2, because this x2 vector is containing how many elements, p minus 1, which are x2 up to xp. So let gx2 up to xp is denoted in this way. Let us say it is a linear function, beta 2 x2 plus up to beta p xp, a linear function of x1 x2 xp. So let us say g is a linear function of x1 x2 xp. So we wish to obtain the best, ये हमारे पास है, we know this, x2 xp is given to us, but these are unknown. These are said to be a beta 2 up to beta p are said to be a unknown. So they are said to be unknown parameters. When you say that the parameters means, when you say that parameters, so parameters are always a fixed constant, but they are unknown. Okay, they are fixed constant, but they are unknown. So to identify the regression, as I said that we wish to know the best value of the g of x1 x2 xp, and we already said that g of x1 x2 xp is nothing but expectation of x1 given x2 xp. So here, if we write this beta in this notation, beta to beta p minus 1, so it has a beta is nothing but column vector having a p minus 1 element, and x2 is nothing but it is a vector of the p minus 1 variables x2, xp, xp. So this quantity we can write as a beta dash x2. तो आप सब जानते ही है कैसे लिखेंगे इसको. रो है तो बीटा टू बीटा टी, और यहाँ पे क्या आएगा x2 x3 xp. So beta 2 multiply x2, it is a beta 2 x2. Then beta 3 multiply x3, it is a beta 3 xp, and beta p multiply xp, it is a beta p xp. But it is a just product of row with the column, so it is giving the addition of the all possible elements. So gx2 xp is nothing but beta transpose x2. Now in order to obtain the best value of the beta, we wish to obtain the best value of beta. How will you obtain? We minimizing the distance. What is the distance? Expectation of x1 minus m, or you can say that the g of x2 xp. इसको हमें minimize करना है, this square. And what is the g of x2 xp? It is nothing but beta transpose x2. So can I write this? This is a quantity. Can I write in this way? Expectation of x1 minus beta transpose x2 into expectation of beta transpose x2 whole transpose. If you remember, I wrote variance of x as the expectation of x minus expectation of x into x minus expectation of x transpose. So this is what I have written here in the same fashion. So if I'm multiplying this x1 with this x1, it is x1 square. This x1 multiply with the beta transpose x2. Beta transpose is a constant because it is a fixed value, because we know that x2 has the certain mean. So here what happened, you can write it as a x1, and this is a beta transpose x2. Okay, so this quantity is here. Beta transpose is beta, so beta is out second side, so it is a expectation of x1 x2 transpose. This quantity multiply with this, it is a beta transpose x2 x1. Beta transpose is outside, so it is a beta transpose x2 x1. And this quantity multiply with this, it is nothing but beta transpose x2. And when you take transpose of this quantity, what happen? It is a x2 transpose beta, it is a beta. So it is a x2 transpose beta, and when you take expectation inside, so it is the expectation of this quantity. Is that clear? ये step सबको? Hello.
Yes, sir.
Okay, it is very simple. It is a matrix algebra result which we have earlier discussed. We are using the same. But what we have, what is the expectation of x1 square? Because the mean is 0, so expectation of x1 square is sigma 1 1. So this is what. And what we call the expectation of x2 x1, it is nothing but sigma 2 1. So it is a beta transpose sigma 2 1 minus this is nothing but sigma 1 2, and this is called beta, so sigma 1 to beta, and plus it is a beta transpose sigma 2 2 beta. So in short, you have to minimize the quantity. Which quantity? It is a sigma 1 1. As I say that, if you take the transpose of this, what will you get? You will get the sigma 1 to beta, and both are the scalar. It is a scalar value. So when they are the scalar, what happen? स्केलर क्यों है? क्योंकि सिग्मा 2 1 का ऑर्डर क्या है? व्हाट इज द ऑर्डर ऑफ सिग्मा 2 1? इट इज ए p minus 1 क्रॉस 1. और बीटा ट्रांसपोज का ऑर्डर क्या है? बीटा का ऑर्डर p minus 1 क्रॉस 1 है, तो ट्रांसपोज का क्या होगा? 1 क्रॉस p minus 1. और इसका ऑर्डर क्या है सिग्मा 2 1 का? इट इज ए p minus 1 क्रॉस 1. तो व्हेन यू मल्टीप्लाई, व्हाट हैपन? द फाइनल ऑर्डर इज 1 cross 1. It means you will get the scalar. तो स्केलर है तो इसका मतलब ये दोनों का ट्रांसपोज लेंगे, यू आर गेटिंग द सेम आंसर. तो इट इज ए this and this, if you add it, it will become the 2 times. So that's why I have written it is a minus 2 times beta transpose sigma 2 1. And this is the beta transpose sigma 2 to beta. Okay, so I wish to minimize this quantity q. I wish to minimize this quantity, and it is also known as a normal equation. When you come to the semester 2, we will discuss about the regression theory. So we will obtain the set of normal equations. So how to obtain the best value of beta? So by minimizing this quantity. And how to minimize the quantity? What are the criteria? To take the first derivative of this particular quantity with respect to beta equated to 0, you can get the best estimate of beta, and obtain the second derivative. And if it is greater than 0, then we say that the quantity is minimized by beta. So that is what I say here. What is the quantity we have? Anybody remember? What is the form of Q? Q equal to sigma 1 1 minus 2 times beta transpose sigma 2 1 plus beta transpose sigma 2 2 beta. So if you remember the, I have said you the some results. X transpose A transpose A, and if you take the derivative of this with respect to A, what will you get? You will get the, what will you get? You will get the X. याद है ये रिजल्ट हमने किए थे? And if you take the A transpose A X, if this is a matrix with respect to A, what will you get? You get A transpose X. Or if this is also a matrix, you will get the 2AX, something like the results we have used. So if you take the derivative of sigma 1 with respect to beta 1, but here any constant beta is present? No. So derivative of sigma 1 1 with respect to beta is become the 0. Constant derivative with respect to beta is 0. Now if you are taking this, what happen? As I say that you will get the, if you say it is a transpose X, then what is that? You will answer get the X, but here 2 is there, so you will get the 2X. So here it is a minus 2 minus 2 sigma 2 1. And what is the derivative of this quantity with respect to beta? It is a 2 times sigma 2 beta. Similarly AX, you can see that. Just substitute the A is equal to beta transpose X, A equal to beta, so it is a beta transpose X A, or if it is a this, you will get the 2AX. So that is nothing but the sigma 2 to beta. And again you can verify what is the order of this sigma 2 1 का order क्या है?
P minus 1 cross 1.
It is a P minus 1 cross 1. और इसका ऑर्डर क्या है? इसका है P minus 1 cross 1, इसका क्या है 1 P minus cross 1, तो इसका भी ऑर्डर क्या हुआ? P minus 1 cross 1 and 0. तो what is the element? It has also a P minus 1 cross 1 element. So now you can just take, divide it both the side by 2, so you will get minus sigma 2 1 plus sigma 2 2 beta. So if you take minus sigma 2 1 in a right hand side, you will get the sigma 2 2 beta equal to sigma 2 1. Okay, so now what is the order of sigma 2 2? It is a P minus 1 cross P minus 1. That means it is a square matrix. Now if it is a square matrix, and if it is a determinant is not 0, that means sigma is a positive definite matrix, then of course their all principal minors are also positive definite. So sigma 2 2 is also positive definite, and when the sigma 2 2 is positive definite, that means determinant of sigma 2 2 is not equal to 0. And when the determinant of any matrix is not equal to 0, that means that matrix is invertible. So we say that the regular inverse of sigma 2 2 exists. And if it is exist, what happen? We can pre-multiply equation 1 both the side by sigma 2 2 inverse. So you can say that sigma 2 2 inverse, sigma 2 2 beta, बीटा की जगह पे अभी क्या होगा बीटा कैप बिकॉज नाउ इक्वेटेड टू 0 किया तो एस्टिमेट आ गया एंड हियर यू कैन ऑल्सो प्री मल्टीप्लाई sigma 2 2 inverse, and that is how you can get this quantity. So sigma 2 2 inverse sigma 2 2, so it become the identity. So you will get the beta 2 cap equal to sigma 2 2 inverse sigma 2 1. So what is the estimate of the beta? The estimate of beta is nothing but sigma 2 2 inverse sigma 2 1. In matrix theory, you have studied the concept of a G inverse. When you say that the matrix A bar is said to be a G inverse of matrix A, when you write A bar A is equal to A. Okay. So when regular inverse is not exist, then we can go for the concept of a G inverse. So here, why regular inverse is not exist? Because if the sigma is a positive semi-definite. So when it is positive semi-definite, it means that the determinant of sigma is not 0. Okay. So at that time, the regular inverse is not exist, and therefore one has to go for the G inverse. And when you find out the G inverse is nothing but sigma bar, so what is the G inverse of sigma 2 2? It is a sigma 2 2 bar, which is a G inverse of a sigma 2 2. So what is the property of G inverse? It is a sigma 2 2, sigma 2 2 bar, sigma 2 2 is nothing but sigma 2 2. Suppose sigma 2 is a regular inverse, then if you substitute sigma 2 2 bar by sigma 2 2 inverse, then this becomes the identity. So you will get also the answer is sigma 2 2. So here sigma 2 2 bar is nothing but generalize of the sigma 2 2 inverse of matrix. So it is also known as a G inverse, and which satisfied this particular property. So what is the estimate of beta 2 cap? Here you can just pre-multiply both the side by क्या प्री मल्टीप्लाई करेंगे तो यहाँ पे आप क्या करेंगे दिस सिग्मा 2 2 goes to this side, so it become the sigma 2 2 bar. So then beta cap is become the sigma 2 2 bar sigma 2 1. तो रेगुलर इनवर्स है तो क्या आएगा यहाँ पे सिग्मा 2 2 इनवर्स आएगा. अगर जी इनवर्स है, जी इनवर्स कब होगा? व्हेन इट इज नॉट ए पॉजिटिव डेफिनेट मैट्रिक्स. ओके, is that clear? So now what is the beta cap? We obtain the beta cap equal to sigma 2 2 inverse sigma 2 1. And what is our aim? Our aim is that we wish to predict the value of x1 based on the given value of x2. So x1 be predicted by, तो x1 को कैसे predict करेंगे? The best value of g of x2, xp is nothing but beta transpose x2. So now if you substitute beta transpose by beta cap or beta by beta cap, you will get the best value of x1. So that is the predicted value of x1 is given by beta cap transpose x2 and beta cap transpose x2. What is the beta cap? So beta cap is nothing but sigma 2 2 inverse. So when you take the transpose, it is nothing but sigma 1 2 sigma 2 2 inverse x2. ये आप सबको पता है ना. बीटा कैप हमने क्या निकाला? बीटा कैप इक्वल टू सिग्मा 2 2 इनवर्स सिग्मा 2 1. So what is the transpose? Is nothing but transpose of this quantity, and we know that AB transpose is equal to B transpose A. So it is a sigma 1 2 sigma 2 1 transpose, and sigma 2 2 is a symmetric. So their inverse is also a symmetric. Okay. So it is nothing but sigma 1 2, and ये क्या है sigma 2 2 inverse. So that is what here I have written. This is called the regression of x1 on x2 x. Okay. अगर आपको पूछा गया है कि गिव द फॉर्म ऑफ रिग्रेशन ऑफ x1 on x2, तो इट इज नथिंग बट x1 इक्वल टू सिग्मा 1 2 सिग्मा 2 2 इनवर्स x2. ठीक है. The observed value of x is x1. So what is the observed value? The observed value is here x1. And what is the predicted value? The predicted value is given by this quantity. And the difference between actually गलत लिखा है x1 on regression line x1 on x2 is given by this quantity, but यहाँ पे कुछ error term आएगा, equal to सीधा नहीं लिख सकेंगे. ठीक है. The observed value of x1 and the predicted value of x1 is ये है, and the difference between x1 and sigma 1 to sigma 2 to inverse x2 is called the residual. So when you say that this is called residual, e की जगह epsilon की जगह हम e कहेंगे. E is a residuals. So what is the residuals? So residuals is nothing but difference between the observed and predicted. So the residual is denoted by, कैसे डिनोट करेंगे रेसिड्यूल्स को? तो इट इज डिनोटेड बाय द x1 डॉट 2 3 फी. यहाँ पे इसका मतलब क्या हुआ? x1 डॉट 2 3 up to p is mean that first variable of x is a function of the rest of variables, is nothing but x1 minus sigma 1 2 sigma 2 2 inverse x2. If it is a positive semi definite, it is a bar. तो आपको पूछे कि what is the form of the regression of x1 on x2 xp. So regression x2 or residuals of x1 x2 xp is nothing but this x1 minus sigma 1 2 sigma 2 2 inverse x2. So given a value of x2, if you know the value of sigma 1 2 and sigma 2 2 inverse and x1, you can easily obtain these residuals. Now if you wish to find out the properties of residuals, so here what is the x1? X1 is nothing but observed value, and this is said to be the predicted value of x1. This quantity is known as a predicted value of x1. So if I wish to find out the variance, how to find out the variance? तो हम जानते हैं आगे निकाला था वेरिएंस ऑफ x इज इक्वल टू एक्सपेक्टेशन ऑफ x माइनस एक्सपेक्टेशन ऑफ x इनटू x minus expectation x transpose. So we use the same formula. Okay, we will use the same formula. So here what is the variance of x1 dot x23p? It is nothing but variance of x1 minus sigma 1 to 2 inverse x2, and this nothing but it is written in this form. Now you can multiply. अब यहाँ पे हमने क्या किया है? This form I have written as it is, और यहाँ पे जो ट्रांसपोज है मैं अंदर ले गया. तो x1 is a scalar, तो स्केलर का ट्रांसपोज क्या है? स्केलर. And if I am finding the transpose of this quantity, it is a x2 transpose sigma 2 2 inverse, and sigma 1 2 का क्या होगा transpose? Sigma 2 1. So this is this, and now I am multiplying and then supplying the expectation x1 into x1, that is x1 square. So it is expectation of x1 square, and this sigma 1 2 sigma 2 2 inverse x2 is multiplied with x1. What you will get? This sigma 1 2 sigma 2 2 inverse is a constant, and then expectation of x2 x1, and again this quantity is multiplied with this. So expectation of x1 x2 transpose, this quantity is constant, तो वो कहाँ जाएगी? पीछे की साइड बाहर निकलेगी. ठीक है. and then you multiply this with this, तो expectation of sigma ये sigma 1 to sigma 2 to inverse बाहर, then expectation of x2 transpose, and this sigma 2 to inverse sigma 2 1 यहाँ पे मैंने बाहर लिया. Now we know that this is nothing but sigma 2 1, so I can have this is sigma 1 square, sigma 1 2, sigma 2 2 inverse, sigma 2 1, and this is nothing but the sigma 1 2, so sigma 1 2, sigma 2 2 inverse, sigma 2 1. So this, and this quantity is a sigma 1 2 2 inverse, this is nothing but sigma 2 2, and this is sigma 2 inverse, sigma 2 1. But this is a identity, so you will get sigma 1 1, this is the 1 and this is the 2, so that is our minus 2 times sigma 1 2 sigma 2 2 inverse plus sigma 2, and this is identity. The what will you get? Sigma 1 2 sigma 2 2 inverse sigma 2 1, but this is minus 2, this is 1, so you will have the variance is sigma 1 1 minus sigma 1 2 sigma 2 2 inverse sigma 2 1. So this is a variance of residuals of regression when x1 on x2 x3 xp, and the variance is given by sigma 1 1 minus sigma 1 2 sigma 2 2 inverse sigma 2 1. Okay, so what is the mean of x1 x2 xp? वो जीरो आएगा, and variance क्या है? This quantity. So I think we will quickly, okay, we have a time, we'll quickly see the properties of residuals. So first we have find out the variance of residuals. Now we see the other property. The residuals is uncorrelated with the regressions. So what is the property? Second property, I am saying that whenever you talk about the regression, then whatever the residuals term, it is residue or residual term, you say they are uncorrelated with the independent variables. So what is the residual term in our case? It is a x1 dot 2 3 p. Okay, I wish to show that these are covariance between this quantity and this is 0, because this is nothing but the vector of independent variables. So we want to show that the covariance between x1.23 up to p and x2 is 0. So it is as good as that I wish to find out the covariance, but when I'm saying that covariance between x1.23p and x2 transpose, it is as good that expectation of this quantity into this quantity minus expectation of this quantity into expectation of x2 quantity. But we know that expectation of the mean is 0 because it is an expectation of residual. So this quantity is 0, so you have finally remain okay. ठीक है, तो इसका मतलब है कि ये 0 रहा, तो इसका मतलब आई विश टू शो दिस एक्सपेक्टेशन प्रोडक्ट ऑफ द रेसिड्यू एंड द p minus 1 वेरिएबल्स इज 0. ओके, क्योंकि ये तो निकल गया, तो ये इंडिपेंडेंट कब होगा? वी नो दैट व्हेन यू से दैट x and y are independent, if you say that the product of expectation of xy is 0, then we say that both x and y are independently distributed. ठीक है, ये हम जानते हैं. So we wish to show that this quantity whose expected value is 0. So let us start with this quantity. Now what is the x1.23p? So we know that it is a x1 minus sigma 1 to 2 inverse x2, and ये x2 ट्रांसपोज है, तो x1 का x2 ट्रांसपोज के साथ एक्सपेक्टेशन ये आया, फिर minus sigma 1 to 2 inverse is constant, then expectation of x2 transpose. But what is the expectation of x1 x2 transpose? It is a sigma 1 2, this is a sigma 1 2 sigma 2 2 inverse as it is, and what is the expectation of x2 transpose? It is a sigma 2 2. So this is identity, so it becomes the sigma 1 2. Here it is sigma 1 2, so sigma 1 2 minus sigma 2 is 1 2 is 0. It is showing that both the residues and the linear predictors, or you can say that the regressors, are independently distributed. When you talk about the regression, this x1 on x2 xp, so these are said to be a regressors. It is also known as a predictor. It is also known as the independent variables. But what is x1? X1 is said to be a regressant. It is also known as a dependent variable. This is said to be a cause, then this is said to be effect. इसको आप cause कहो तो ये क्या हो गया, effect. ठीक है. So there are various names are there. So the second property that we have show that the residues are uncorrelated with the regressors. That means they are independent with each other. So earlier, whatever we have obtained about the concept of a regression, but if I wish to find out the multiple correlation, so we know that the simple correlation is nothing but correlation between two variables. But if you wish to find out the correlation between with one variable and set of variable, let us say y cap, so that is said to be a multiple correlation. So if I wish to find out the correlation between the x1 and set of variable h2, इसके अंदर कितने एलिमेंट है, 1 है, इसके अंदर कितने है, p minus 1. If I wish to find out the correlation between these two, they are said to be a multiple correlation. तो वो देखेंगे हम नेक्स्ट लेक्चर में. Any questions so far, anyone? Any questions?
No, sir.
So this is very important things. How to obtain the regression x1 on x2. So what is the form of a regression of x1 on x2 up to xp, where x2 up to xp we denote as a column vector x2. So regression on x1 on x2 is given by sigma 1 2 sigma 2 2 inverse x2. And what is the residue? The residue is denoted by the x1 dot x2 up to xp, which is given by the x1 minus sigma 1 2 sigma 2 2 inverse x2. Okay, and what is the mean of residue? Mean of residue is 0. And what is the variance of residue? Variance of residue is nothing but, because x1 dot लिखा है, that means x1 का variance क्या आएगा, sigma 1 1. डॉट के बाद जो है वो माइनस में आएगा, तो कौन सा है, x2 up to xp, तो it is nothing but sigma 1 1 minus sigma 1 2 inverse, sorry, sigma 1 2 sigma 2 2 inverse sigma 2 1. And further we show that the residues and x2, that is regressors, are independently distributed. So how we obtain the best value of the g? G is nothing but function of x2 xp. So we say that, let us say g is a linear function, and which is denoted by the beta 2 x2 plus beta 3 x3 plus up to beta p xp. So we wish to obtain the best value of the beta p. So how to obtain the best value of beta p? Let us minimize the quantity x1, expected value of x1 minus g2, or g of x2 up to xp whole square. That is, you are minimizing the quantity expected value of x1 minus beta transpose x2 whole square. So how will you minimize? You have to just simplify that quantity, take the derivative with respect to beta, equate it to 0, you will get the estimate of the beta. And what is the estimate of the beta in the regression x1 on x2? It is saying that if the sigma that is the variance covariance matrix of X is positive definite, then the partition matrix, the variance covariance matrix of X2 is sigma 2 2 is also positive definite, so it is a invertible. So the beta cap is nothing but sigma 2 2 inverse sigma 2 1. Okay, and similarly, if it is a not a regular inverse exists, then you have to find out the G inverse. So we say that sigma is a G inverse, so sigma bar is known as a G inverse of sigma, which satisfy the property sigma sigma bar sigma equal to sigma, then we say that sigma bar is a G inverse of sigma. So when there is a need to obtain the G inverse, when your matrix variance covariance matrix is a positive semi-definite, or you can say it is not a positive definite, at that time we require to obtain the G inverse. Okay, and because the sigma is a positive semi definite, तो partition matrix जो आप निकालेंगे sigma 1 1 sigma 1 2 sigma 2 1 sigma 2 2, so sigma 2 2 is a p minus 1 cross p minus 1 matrix. It is a variance of x2, it is also a G inverse, and therefore at that time the regression x1 on x2 is estimated by beta 2 cap, where beta 2 cap is nothing, beta 2 cap x2, where beta 2 cap is nothing but sigma 2 2 bar sigma 2 1 x2. Okay, any questions, anyone?